All right, I've got a pretty ambitious set of notes today. A lot to go over. We got through it just fine in fourth period, so we'll see how it goes here. Extra class time, yeah, they had some time to start their homework. So, actually, it's close to 10. Yeah, so we'll see. Okay, let's start with your warm-up. Okay, first one should be pretty self-explanatory. It says, what are the x-intercepts of the function graph below? Now, what's an x-intercept? Awesome. How many times does that happen here? Okay, so go ahead and mark on your paper where those happen. And then if you could please tell me what those ordered pairs would be. Does anybody have any questions on those? Everybody's good? Yeah? Okay, let's go over to the circle and square problem over there to the right. It says, Ayana, place a circular piece of paper on a square picture as shown below. Does everybody see what's going on in that picture there? Yeah? It says, if the picture extends 4 inches past the circle, what is the perimeter of the square picture? Now, first of all, what's perimeter mean? Outside. Well, I don't really know how long this is because I only know that from here to here is 20, right? So is there a way that I can find the rest of it? What'd they tell me? 4 inches on each side, right? So this piece over here is 4, agreed? And that piece over there is 4. So really, how long is it? It's really 28. And if that side is 28, what are all the rest of the sides? 28. So if you add them all up, or if you multiply by 4, what's the perimeter? No. Listen, you guys will not survive this class without a calculator. You just won't. What is it? 112, which would be letter J. Okay, let's go right below it. It says, which is greater than 64 and 1/3? Well, I don't really know what 64 and 1/3 is until you put in your calculator. So can you tell me what 64 and 1/3 is? 4? All right, so I got to figure out which one of these is greater than 4. Well, what do you get for letter F? Is that greater than 4? No. What do we get for letter G? 2? Is 2 greater than 4? No. How about letter H? 8? Is that greater than 4? Sure is, so I don't even need to check letter J. Does anybody have any issues putting those exponents in their calculator? We're okay? Yeah? All right, a last problem here. It says Hinto invested $300 into a savings account, and the equation models the amount in his account A after T years. How much will be in his account after 7 years? Okay, well, what do I have to do to figure out how much money he's going to have? What do you think? No. What information do they tell you here, folks? Okay. Guys, I'll wait. I am not going to sit up here and regurgitate this information to you. Look at it, reason with it, problem solve it, and tell me what needs to be done here. What do they tell me? What do I know? What needs to happen? Okay, so did everybody see how that $300 is already in the equation? Okay. What else do we know? T is for years. Does everybody see how it says right here, T is years? Yes? And how many years is he going to leave it in there? 7. So he's got to put the 7 right in there for T. So let's go ahead and do that. So that's multiplication up there, isn't it? Yeah? What do you get? I just want to know what this part is up here. What is it? So this exponent is actually 84. All right, the rest is for your calculator to do. Got an answer for me, Dalton? So letter B? Awesome. Does anybody have any issues with that? Now, in your calculator, that one that you're using there, you're going to have to do this 1.005 to the 84 first, and then you're going to multiply it by the 300. That makes sense? Anybody have any question on the warm-up? No? Okay, so the first couple things I want to talk about are these two graphs. Good? Okay, two graphs. I hope I don't really need to use this one. I think it's going to probably go pretty well on this one, that I don't even have to use the one on the right. So how do you read this up here? F of 1. Now, normally we see this as f of x, correct? So what has been substituted in for the x? A 1. Well, can I find x is 1 somewhere on this graph here? X is 1 is right there. Does everybody agree with that? So follow it up to the line. What's the y value there? Yeah, so my answer to this problem is going to be 1 because the x value is 1, and that gave me a y value of 1. Is that all right for everybody? Okay, how do you read that middle one up there? F of -4. So this time, what's the x? So go to where the x is -4, which is right there. Follow it up to the line, and you tell me 6. Wonderful. And finally, the last one says f of 0. So go to where f is 0 or x is 0, and you get a 2 right there. How is that top row? Pretty easy, right? Okay, so let's go to the bottom row now. Now this says f of x equals 9. So do I know the x anymore? I don't, because see how it actually has an x in there. What do you think I know this time? The y. So the y is 9 in that first problem. Go to where the y is 9. That would be right here. Follow it to the graph. -7. And then let's do that for the second one. That says f of x is -2. So go to where the y is -2. Follow it to the graph. Dylan, did you say 4? Wonderful. Guys, how do we feel about that? You can handle that, right? I don't need to do this other graph over here. No? Fair enough? Okay, so let's go on to the back. This is the good stuff for today. This is what we're going to be talking about. So it says a linear function. Guys, what does the word linear mean? A straight line. And what kind of equations are straight lines? What form are they in? If you're going to graph a line, what form does it have to be in order for you to graph your points? Y equals mx plus b. Slope-intercept form, right? Now, you should remember what all those pieces and parts stand for. What does the b stand for? The beginning, that's the y-intercept. Perfect. What does the m stand for? The slope. Now, when I do the slope, does it stay the same the whole way through, or does it change? If my slope is 1/3, I do up 1 over 3, up 1 over 3, up 1 over 3, forever and ever and ever, right? Because that line is going to stay straight. If it changes, won't that line kind of curve and do all that other stuff? Okay, so linear functions are typically used to represent consistent change, meaning it does the same thing every single time. Up 1 over 3, up 1 over 3, up 1 over 3 for the end of eternity, right? Okay, we just kept going and going and going. That's a line. Okay, now, does everybody see how I use this word function right here? Function is normally f of x, isn't it? Now, I need you to understand that y equals mx plus b is the same as f of x equals mx plus b. They mean the same thing, just instead of y, I'm using f of x. Is that all right? We following that okay? All right, so now for the good stuff for today. We have exponential functions. What word do you see in exponential? Exponent, right there. So we are going to have exponents in an exponential function. Fair enough? Okay, so it's going to look like this. And I have that written over there in blue because we're going to use that quite a bit today. Yep, and I'm going to go off of the screen, so I'm going to have it over there so I can see it. Okay, so then if that's my equation, can somebody tell me how to write this as a function? How's everybody doing? Do you see how we made that change from y to f of x? Hello? Is this thing on? Yes? Yes? Okay, so let me tell you the pieces and parts to this thing. What did b stand for in the linear function? The beginning, guess what? This B also stands for the beginning number. Okay, just like it did before. Then this A stands for the percent of change. Percent of change. Folks, what are percentages always out of? 100. You need to make note that you will always start at 100. That's always kind of going to be your base number is 100. Okay, so the question is, when do we use these? We're going to use exponential functions to show a percent of increase or decrease. You also will use you also will use an exponential function to double or half or triple something. Double or half or triple. All of that is exponential functions. All right, so now we're just gonna do it. Okay, I've got what, 5 problems there? 5, 6 of them, 5 of them. We're gonna make a function and then we're gonna plug something in, and that's gonna be it. Good? Okay, first thing I want you to do is read those directions, the bolded piece at the top there, before you start reading. What am I going to have to make for all of these things? A function. So it's got to look like f of x, right? Okay, so here we go. It says the population P of deer in Hamilton County has decreased by approximately 5% yearly Y. Okay, stop right there. Is it going to be f of x? What variables am I telling you to use? P and Y, correct? So it will be P of Y. Okay, P of Y. Now, I'm looking at this thing over here, aren't I? This is exponential. Do you see how it has a percentage in it? How it says 5%? So I know that I need to use this thing. Good. B is beginning number. How many deer did I begin with? Nope. How many deer did I begin with? 19,500. Is everybody good with that B number? Now, the A was percent of change. Now, what did I tell you the percents are always out of? 100. So I'm going to start at 100. What is happening to my population? Is it going up or going down? Down by how much? So I'm going to go down by 5. What does that get me to? I am now at 95%. But you should have learned, probably in 5th or 6th grade, that you cannot use, I kind of ran out of room here, you cannot use 95% as it is. You have to move the decimal place. You remember how many spots? 2. 100 has 2 zeros on it, correct? So we move our decimal place 2 spots. Where is the decimal right now? So that if I move it 2, what's it going to be? Awesome. So my A number right here is going to be 0.95. How is that for everybody? Do you see how it's less than 100? Because we went down, correct? Does that logically, doing okay? Does that logically make sense to you? Okay, now I need a power up here. Over here I had x, but I'm not using x in this problem. I'm using what? Y. Okay, there's my function. Basically, we just filled in all the pieces of this equation over here. All right, so now I got to answer a question. It says, estimate the deer population in 2025. Folks, what year did this population begin in? Does everybody see how this says 2015? So how many years went by? 10 years. Where do you think I'm going to put the 10? In for the Y, because isn't Y for years? So we're going to plug in 19,500 times 0.95 to the 10th power. And then your calculator is going to do the hard work for you. Okay, so Derek, for yours, you're going to do the 0.95 to the 10th, and then you're going to multiply it by the 19,500. Is that okay? Okay, now don't tell me the number that you have on your screen, because chances are that number is going to be a big old long decimal, correct? Now, I can't have a decimal of a deer. Well, I suppose technically I could have a decimal of a deer. Okay, but I'm not going to. Okay, nobody's cutting up deer, and we're just going to do whole deer. Fair enough? Look at your number on your screen. Is it something you should round up to the next number or down to the previous number? And what would that number be? 70 what? Like that? And that would be my final answer. So I had to write an equation first, then I had to plug it in. Got to label it. Deer, right? Bless you. How's that? Better? Awesome. All right, let's do it again. It says the number of bacteria B grow exponentially at a rate of about 150% per minute M. Okay, what variables am I using? So B of M. All right. I need to know how many bacteria I started with. Nope, how many? Gotta read carefully. 2 bacteria. So this B number right here is a 2 because I began with 2. Now, folks, what percentage am I doing here? Now, do you see how they already started at their 100 and now it's at 150? So is my population going up or down? Up by 50% because it's already over the base of 100. Fair enough? Now, I can't use this 150% the way it is. I have to move my decimal how many spots? 2. So where will it be? Awesome. This will be 1.50 or 1.5 to the M power. Good. What does M stand for again? No. What does M stand for? Minutes. M stands for minutes. Do I know how many minutes this is going to go on for? 15. So what am I going to do with that 15? Put it in for M. So after 15 minutes, my 2 bacteria are going to multiply to how many bacteria? Is it a whole number? Let's make sure everybody... Which way am I going, up or down? Is it 0.5 and above? So we're going to go up, right? So what is that going to be? 876 bacteria. What do you guys think about this so far? It's okay so far? So far, so good? Okay. Number 3. What are we talking about this time? Ooh, money. Money. All right, go ahead and read it. You tell me what variables I'm going to use. Which way is it going to go? Is it T, S of T or T of S? Correct. S of T. Do I have a starting amount? That'd be nice, right? 10,000 bucks. Now, did they tell me how much this is going up or down by every time? Now, what am I supposed to start at? 100, right? And I'm supposed to add 7. So now I'm at 107. Is that okay for everybody? Where's the decimal place right now? So if I move it twice, where am I at? So that is going to go in the parentheses. And then what variable is going to be my exponent there? T. And what does T stand for? Years. Well, what year did we start in? And what year do I want to go to? How many years is that? 25 years? So what am I going to do with that 25? 4T. Got it. 54,270. Now hold on a second. This is money, right? So can I have decimal? I can have cents, right? 35. Well, what was after the 7 again? 4. And then you said 35 cents? Well, that'd be nice. I let my money sit there for 25 years. Oh, 33 cents, excuse me. Excuse me. I let my money sit there for 35 years. And now 10,000, that's a lot of money. 10,000 turned into 54,000. Now 25 years is a long time, right? I mean, a long time. So far so good, guys? Yeah? Yes, sir. On your calculator? Okay, so ready? Let's do 1.07 to the 25th and then hit equals. And then times that by 10,000. And let's see if we came up with that 54,000 number. Are you okay now, though? We're good? Okay. How's everybody doing? Now, I need you to understand that most all of these problems that except for the first one, everything's been increasing, right? Okay, we could also be decreasing, like in the first one where we subtracted. All right, number 4. Read it to yourself. To yourself. I need to know the variables. S of y. Do we have a starting number? Now, what happens with this percentage? So I started 100. I'm increasing by 75. So now what am I at? But I can't use 175. I have to move it 2 spots to 1.75. To the what power? Y. And what does Y stand for? So we started in 1985, and now I'm looking at 1994. 9 years. So we're going to take that 9, and we're going to plug it in. I gotcha. Except you're going to have to meet me halfway because I don't think my cord's going to reach. There we go. I'm sorry. I said I'm sorry. That is people. Okay, so ready? Do. Okay. Got a number for me? Okay, now I want you to round it to the nearest whole number because we have people going on here. Like that? Good? We're bringing it up from 71. Guys, this should make sense to you. Cell phones kind of took off, right? Oh, yeah. You okay or no? Let me see the number on there. $1.75 to the 9th power times 285. I think you must be hitting your buttons wrong, a little bit wrong. Is that okay? Yeah? All right, do I just have one more left? Okay, read it. Oh, you want me to go back? Sorry. Correct. So what's my variables here? P of R. Do I have a starting number? Now, does everybody see how it says half? What do all percentages start at? What's half of 100? But you can't use 50%. You have to move it 2 spots, and it'll be 0.5 or 0.50 or 0.5, however you want to write that, to the what power? Well, it's going to be R, and then I'm going to plug in 5. Yes. So 256. So how many people are left after 5 rounds? 8 people? 8 tennis players left after 5 rounds. So question for you. How many more rounds do they have to play before they have a winner? If I have 8 people left, one more round gets me down to... No. If there's 8 people left, how many people play each other in tennis? 2, right? So that brings me down to 4 for one round. What about the next round? Now I'm down to 2, and then now I got the championship. So I got 3 more rounds in this tournament if I want to have a champion. Questions for me today? You are fast. I told you. You thought I was kidding you when I told you you'd have time left. I know. Most of these notes is like the words take up a lot of space. So, All right, I have a worksheet for you. That's going to be your homework. You are not going to do the very last one, though. So you're going to cross off the very last one. I got too many papers. I don't want to mix up.
Let's see, Marty. Yeah, you keep doing it, Marty's like the same.